Jain student. My name is Pardeep and I am working as an assistant professor in IT department in Ajay Kumar Garg Engineering College, Ghaziabad. Today we will discuss the subject Basics of Database Management System, whose code is KOE067. So today we will discuss keys in database management system. Okay. So it is very important. So there are various types of key in DBMS. So DBMS basically stands for Database Management System. So DBMS stands for Database Management System. Database Management System. So there are various types of keys in DBMS. So there is candidate key, there is primary key, another one is secondary key, next is unique key, next is composite key, next is surrogate key, next is partial key, next is foreign key, alternate key and super key. So there are various types of key in DBMS. So we will discuss some of one of most important keys in DBMS, which are basics of DBMS key. So there are basically 10 important keys in DBMS. One is super key, next is candidate key, next is primary key, next is alternate key, next is foreign key, next partial key, composite key, unique key, surrogate key and secondary key. So let's see the super key. So what do you mean by super key? It is a set of attributes used to differentiate records uniquely, which may not be minimal attribute set. A super key may consist of any number of attributes. For example, so here schema is given. So there are attribute student ID, student name and age. So this is the relational schema. Okay. Now the candidate key here is, it is given that student ID. Now what are the super key? Super key means it is set of attribute used to differentiate records uniquely. These key differentiate records uniquely but may not be minimal. It is not necessary that set of attributes are minimal. So here SID is candidate key. So candidate key is minimal super key. So what are the possible super keys here? Student ID, it is one of the super key. Student ID and student name combinedly is known as super key. Here S name, student name is extra. Next, student and ID and age combinedly is also one of the super key. Student ID, name and age is also super key. So there are 4 super key. So 1, super key 1, super key 2, super key 3 and super key 4. These super keys are not minimal. Let's see the example of, see here, student ID, student name and age. These 3 attributes are combinedly known as super key. But if I remove age, still student ID and student name uniquely identify all the records, but this is also not minimal. Now if I remove student name, now this student ID is sufficient to identify all the records. So this is super key. This is super key. But now I cannot remove more attributes, so it is a candidate key also. So it is a super key also and it is a candidate key also. Next, see the candidate key. Next is the candidate key, a set of minimal attributes that can identify each tuple, So here tuple means each record, each row. Okay, so you can say that, we can also say tuple is row, or you can say record also. So tuple, record and row both are same things. So a set of minimal attributes. So here the keyword is minimal. So minimal set of attributes that can identify each tuple uniquely in the given relation. Is called as candidate key. In short, we can say minimal super key is known as candidate key. So minimal super key is known as candidate key. Suppose I have student ID is able to identify all the attributes, and student name and student ID also able to identify all the records, and student you can say branch, these all three able to identify all the records, but these set of attributes are not minimal. These set of attributes are not minimal. So if I remove student branch, still I am able to identify all the records uniquely. Okay, if I remove student name, still I am able to identify all the records uniquely. Now see, this student ID sufficient to identify all the records uniquely, and it is minimal. Okay, so here the meaning is not minimum, meaning is sufficient. Minimal, sufficient. Okay, sufficient. So minimal is different from minimum. So it is minimal set of attributes that can identify each tuple uniquely. Next, see, there are some points that all about the candidate key. All the attributes in a candidate key are sufficient as well as necessary to identify each tuple uniquely. So candidate keys are sufficient to identify each tuple uniquely. Removing any attribute from the candidate key fails in identifying each tuple uniquely. So removing any attribute from the candidate key fails in identifying each tuple uniquely. So let's see one example for this. So suppose A is one of the attribute, B is one of the attribute, C is one of the attribute. So these three attributes combinedly form the candidate key. So these attributes combinedly form the candidate key. So if I remove C, so this will be no more candidate key. If I remove B, this will not be candidate key. If I remove A, this will not be candidate key. So I cannot remove any of the attribute. Okay, so I cannot remove any of the attribute. I cannot remove any of the attribute. Okay, I cannot remove any of the attribute. Next, see, the value of candidate key must always be unique. Okay, so it always you can say have unique value. The candidate key can have the null values. It is possible that candidate key can have null value. Next, it is possible to have multiple candidate key in a relation. So multiple candidate key is also possible. Next, see, those attributes which appear in some candidate keys are called prime attribute. So what it means, suppose the candidate key, A, B, C in a given relation. In given relation R, and relation is given as A, B, C, D and E. So here prime attributes are those attributes which belongs to candidate key or primary key. So there are two types of attribute. One is prime attribute. So here prime attribute are A, B and C. Next, there are one more type of attribute, non-prime attribute. Non-prime attribute. So non-prime attribute are those attributes which are not included in the candidate key. So D and E are the non-prime attribute. Okay, these are the non-prime attribute. Next, see some important point about candidate key. So candidate key, first one is simple candidate key. So candidate key with only one attribute is known as simple candidate key. Next is compound candidate key. Candidate key with at least two attribute. So there may be two or more attribute. Okay, that is known as compound candidate key. Next, the prime attribute. Attribute which are belongs to some candidate key of the relation. Okay. Next is non-prime attribute. Attribute that does not belong to any candidate key. Just like in the previous example. So D and E are not belong to any candidate key. So these are the non-prime attribute, and ABC belong to the candidate key ABC. So these are the prime attribute. Next, see the primary key. So any one candidate key with field value must be not null is known as primary key. Okay, so suppose there are set of attributes. So there are many candidate keys. So candidate key, suppose C1, C2 and C3. So there are three candidate key and one candidate key is selected as primary key. One candidate key is selected as primary key. Okay, and primary key does not have any null value. So primary key is not null. There is not any null in primary key. So what do you mean by null? Null value are unknown values or unexisted values. Null values are unknown values and unexisted value. So there are some constraint of primary key. So primary key must satisfy candidate key constraint. Next, null value are not allowed over primary key field. Next is at most one primary key. At most one primary key allowed for any database table. Means the maximum primary key in any database is 1. So there is always only one primary key. Okay. Next, see the relation between primary key, candidate key and super key. So super key is the set of attributes that identify all the records uniquely. Okay, so these are not minimal, not necessarily minimal, not necessarily minimal. Okay, so minimal super key is known as candidate key. So minimal super keys are candidate key, and from many candidate keys, one of the key is selected as primary key. One of the keys selected as primary key. So every primary key is a candidate key, and every candidate key is a super key. But reverse may or may not be possible. May or may not be. Not always. It may or may not be. May or may not be means a super key may or may not be a candidate key. A candidate key may or may not be a primary key. Next, see the alternate key. So see the concept here. So there are various keys: candidate key C1, C2 and C3. Among these candidate key, one of the keys selected as primary key. Remaining keys are known as alternate key. Remaining keys are known as alternate keys. Remaining keys are known as alternate keys. So see this one. All candidate keys except the primary key of the relation are the alternate key. All candidate key except the primary key of the relation is known as alternate key. So alternate key can have null values, and here what is null means unknown value or unexisted value. Constraint of primary key, or you can say alternate key. Okay, so alternate key must satisfy candidate key constraint. Okay, so constraint are same as that as of primary key or candidate key for the alternate key. Next, null values allowed over alternate key field. So this is very important, that null over primary key null is not allowed. Over primary key null is not allowed, but over candidate key and alternate key null values are allowed. Okay, null values are allowed. Next, see, more than one alternate key are allowed for any database table. So there may be more than one alternate key in any database, but primary key is always one. Primary key is always one. Thank you.